Now, our question here, this time we have this area, which is the intersection of a semicircle and the parabola there. So, and also the y-axis. So the area there is rotated around the axis, and we're going to use cylindrical shells to do that. So, because we're rotating around the y-axis, it's going to be delta x. So we pick a point x there between it. We know our radius is going to be x. So that's 2 pi x. That's not too bad. But we're going to have our difference in our y values there. So we look at that. We get when y x is we put x in, we get root 30 minus x squared, and we got the minus and we got the x squared there. So that's where our height's going to come from. So we allow us to do our equation there. So we also need to get our points of intersection. So we're going between 0 and this value here, because that's our x value. But what is that x value? Well, we have to solve them simultaneously, and we can't get that, because that's going to give us complex solutions. So it doesn't work. So it's either minus 5 to 5, but we only had that one there. So we get x is equal to root 5. That's going to be our limit of integration. And our volume, 2 pi x and times our root there. So that's what we're going to be left to integrate. Looking a little bit hard, we get our 2 pi out, we multiply, we get x cubed, that's not too bad. But this one, we've kept the 2x, 2 pi in there with this one, or 2x there. But if we recognise that derivative of 30 minus x squared is 2x, so we're placed for a reversal of the chain rule. That's why we get a minus 2/3 coming out, because the 2x is there, but we want the 3 on 2, which is one. If we put it on 3 on 2, that gives us the 2/3 there. Multiply, if we differentiate that out, it gives us 3 on 2 times 2/3. Just get the minus 2x there. So it's a reversal of the chain rule, which is very nice. Makes life easy if we can recognise it. Don't have to do any substitution. And then we integrate the 2x cubed, gives us 2x to the power 4 on 4. And we can do some cancelling down and do our substitution. And we end up with our answer there, 13.7 pi units cubed. This time we got another of these type of ones where we've got no axes. So it's an underground reservoir that's being formed there. And they're going to be rectangular sections, but they're getting bigger in terms of the rectangles. So again, our typical cross section, we're going to label X and Y, but we want to get it in terms of H, which is our height of that, and have our limit of integration be from 0 to 15. So we've got 10 and 12 there, and 23 and 29 as the outsides at the top and bottom there. We want to do what we did before and get an area in terms of H. So we set up our cross sections there. So we get our typical cross section from one way, where we've got X, it's 15 there, it was 12 and 29 there. So if we create two triangles there, we're able to get some functions where that would be a 8.5, because that's 12, split it up, let's still got that symmetry happening. This is x half outside of x minus 12, and we're able to create the similar triangles there with the h on the 15, and these two sides being in the same ratio. Cleaning it up, we get our value for x as 17h on 15 plus 12. So there's our two triangles when we want to compare them. We do the same for where the side of y, 23 across, 20 and 10 on the bottom. Again, the 15, so the h on 15 there. We've got 6.5 and half outside of y minus 10. Again, get those similar those ratios happening, and we're able to get y as that expression. So check the algebra there. The area comes out to be those two, and we get expression as needed. And then we're just integrating between 0 and 15. So even though our numbers are ugly, it's not a hard integration. And then a substitute of 15, because 0 is going to cancel everything out to get 5350. Question 10, again, this one is another one that's a little bit tricky because it's between two curves. So we've got the parabola 3x minus x squared, the line y is equal to x. So again, cylindrical shells are being used. So it's going to be thickness of delta x, because our thickness is there, it's rotating around the y-axis. And really, we're going to get our radius of x, and the y value is going to be the difference between there. So we get our height as that difference between the two y values. So we put that into the area formula, and we clean it up to get the expression there, which we can then integrate. Our values are 0 to 2 because that was the where they intersected, 0 there and 2 there. So there's our value. There are limits of integration. So it's not too hard an integral there. It's just making sure that we're getting our correct difference in our y values to get our expression as needed. So just take a little bit of care with that and make sure we get our signs correct so we can get it to be the correct expression.